Let's discuss about a very interesting topic today, which is called Doppler's effect. Now, Doppler's effect tries to establish a relationship in between the wave frequency of a certain type of a source and the observed frequency of an observer. A very specific example would be that, let's say that this is the source of a certain type of a wave. Let's say, for example, this is sound. Now, if an observer is standing over here and the frequency, the wave frequency of this source is termed to be nu naught, and the wave frequency that is observed, that is experienced by this observer is nu, then if both of these are stationary, that is the source and the observer are stationary, then we could say that nu naught is equal to nu. But what would be the case if the source is moving towards or away from the observer? Well, the Doppler's effect tries to establish a relationship in between the frequencies in such a case, when the source is moving towards or away from the observer. Now, how would the case actually be? Well, the Doppler's effect says that when the source is moving towards the observer, the experienced wave frequency would be much more than the actual source's frequency. But when it's moving away from the observer, the experienced wave frequency of the observer would be much less than the actual wave frequency emitted by the source. Okay. Now, we also need to note down that the study of the Doppler's effect varies when you study light as opposed to studying sound. Today we are here to discuss only the Doppler's effect when it comes to studying sound. So let's proceed with it, shall we? Let's say that the sound source is given by this particular figure, and the sound source is located in the same plane as your observer. Now, in this case, let's say that both of them are stationary. Of course, this is the source. And as discussed previously, we know that if nu naught is the frequency of the waves that are emitted by the source, and nu is the observed frequency, and if both of them are stationary, then we would say that nu naught is equal to nu. But if the source is moving towards the observer, the nu that is the observed frequency by the observer will be much greater than nu naught. But if it's moving away from the observer, the nu will be much less than nu naught. Now this can be described with the equation that is nu is equal to nu naught times 1 plus v over c, 1 plus big V over c. And here, of course, this small v over here, v, is told to be the speed of the observer, considering that the observer is moving with respect to the source. And the big V over here, the capital V over here, is termed to be the speed of the source, considering that the source is moving. Now, V, the big V, the capital V over here, is considered positive if it's moving towards the observer, but it's considered negative if it's moving away from the observer. Now, this fundamental equation can be used to describe the wave frequency observed by an observer in case it's moving towards or away from a certain type of a wave source. Well, that's all for today.